Hello everyone, let's take a look at this problem which is Permutations 2 from LeetCode. Now this is an advanced version of the problem Permutations 1. In this problem, the elements that are present in the given input might be duplicate. To understand the solution to this problem, let's first take a simple example from Permutations 1 where all the elements are unique. So let's take 1, 2, 3 as an example. So in unique case, what do we do is we iterate through the given input, and at each position we try out all the remaining elements at that position for the current position and then recursively pass the remaining input to our recursive function. For example, if we are at 0th position, we will fix 1 at this position, and the remaining part, which is 2 and 3, we pass this remaining part to our recursive function to get all the permutation for the remaining part. Similarly, in one iteration or at 0th position, we will again try out the second element, which is 2, and pass on the remaining part to our recursive function. Now how do we get 2 at that position? We swap at each position. So first of all, we swapped the 0th element with itself, then we swapped the 0th element with 2, and then we pass the remaining element to the recursive function r. This takes the given input vector, the position at which we are fixing the elements, in this case which is 0th position, and the result if we are passing it by reference in case of C++. Now switching back to our original problem, which is Permutations 2, which means that in the given input, for example, let's say we have 1, 1, 2, 2. Now in this input we have duplicate elements. 1 is also duplicate, 2 is also duplicate. So how do we solve this problem? So at each position in the iteration, as we discussed above, we'll try to fix one element. Let's say we fixed 1. Now we want the permutations on the remaining part. We want a recursive function to return all the permutations on this part, which is 1, 2, 2 and 2. Now suppose it returned us some permutations, and we have the permutations at our hand in the result stored. Now we will not swap this one with the next one again, because the remaining part will again become the same, which was 1, 2 and 2. This part is same as above. So this recursive function will again return us the same number of results, and the permutations would be duplicate. So we do not want to count the result twice. So that is why we just want to place the unique elements at each position. So at 0th position, now we want 2. This was an invalid placement. So we want to figure out a way to place unique elements at each position. To track unique elements at each position, a simple approach that comes to mind is maybe we can use a hash set for each position to track the unique elements. So whenever we are trying an element at a position, we'll first check whether it is present in the hash set or not, and if it is present, we'll try out the next element. If it is not, we'll insert it into the hash set and then try it out. Or another approach can be, since while iterating through the array we are not concerned about the order of the remaining elements, maybe we can break down the input in a hash map. So if the given input is 1, 1, 2, 2, we'll maintain a hash map where the elements and their frequencies are stored. So the key will be the element and the value will be the frequency in which they occur. So in that case, our recursive function would look a bit different. In that case, our recursive function, instead of taking the vector, it would take our hash map, and this hash map will just contain the frequencies that are remaining. For example, if we are trying out 1 at the 0th position and our input was again 1, 1, 2, 2, when we pass the remaining part to the recursive function, the frequencies should look like 1 corresponding to 1 frequency and 2 corresponding to 2 frequencies. So we have ideally decremented 1 frequency while trying out 1 at this position. One thing to remember here is to backtrack effectively. So if you have solved permutations 1 problem, we backtrack in that one as well, and similarly we have to backtrack in this one as well. So this was about the explanation of this problem. If you have liked the explanation, do give a like to the video and subscribe to the channel for more such updates. Thank you.